Okay, so let's do in class 13, number 1. So suppose the sample below represents the salaries of a random sample of 30 people in Lancaster. Suppose the population mean salary of people living in Lancaster 5 years ago was $42,000. Write the R code that does the following. Okay, so here's our salaries here from our sample, and here's our questions. So let's just above our sample, let's start our R code. Okay, so A, to do Boxplot. So it's going to be of our sample. So it'll be spelled exactly like this. Sample, capital S. And then the main title is telling us salaries, people. So let's go here. Let's take this and paste it here for our main title. Salaries of 30 randomly chosen people in Lancaster. And then our color is tells us to make it blue. Okay, so that should be your box plot. Oh, I just noticed I forgot a quotation mark here. Okay, so let's take away part 8 and we're done with that. So part B now computes the mean standard deviation of sample data. So print mean of our sample. This is right in mean. Our sample is this guy here. Next we'll do the standard deviation. Oh, forgot a quotation mark here. Now we'll do standard deviation, so print standard deviation. There we go. Standard deviation of our sample. That will be SD, so sample. Okay, so we've done A and B. Take away B now. Next performs a t-test, two-tailed. Let's go up to the top here. Take our template. Bring it down. Go right here. Paste it. Okay, so our data here is sample. Changes the sample. We don't have a second vector, so it's a one sample test. So it says performs a two-tailed, so that's going to be two-sided here. So choose two-sided. The mu here is that so it's going to be that, in this case, it's going to be that the mean salary is still $42,000. Let's see, so mean, so our mu, null hypothesis is 42,000, so don't write any commas in the numbers, I mean. Then paired is not paired, so you can take this away. It's just a one sample. And variation, var equal, don't worry about that too, take that away. Now 1 minus alpha, or alpha value here is 0.05. So I have then 1 minus 0.05. You can check that's 0.985. So that's going to then go in place of this guy. Close this guy here. Okay, I'm going to keep C there. Then it says paste your R code in to run our script, so let's do that. So here it is, starting here, down to here. So let's go to run our script. So here it is. Okay, get rid of this, paste, run it. There's a mean and stuff like that, and our box plots at the bottom. So let's paste this at the bottom below all our directions here. So right here. And then paste the box plot also. There's a box plot. Copy image. Paste. So looking at the box plot, it looks like the median salary is still around $40,000. Okay, so let's keep going here. So we've done then paste it, and we've paste output at the bottom. We've done D and E now. So now let's do F. Let's put F at the top here. At the top of our code, so right here. So it says looking at the p-value in our output, decide. So let's see. Let's find our p-value. Our p-value is right here. Let's take that. Put it below part F here. Okay, so now let's keep going. So it says, looking at a p-value in the output, decide if there is evidence to suggest that the population mean salary has changed from $42,000. Okay, so that's that. So I'm going to write my conclusion here. So here's my conclusion. So looking at the output, we have p-value is 0.5525. Now our alpha, so if you go down there, our alpha is this guy here, 0.015. So our alpha value is less than our p-value. P-value is the 0.5525. Implies that the evidence does not suggest that the population mean salary has changed from $42,000. Okay, so we're done with question 1. Let's go on to question 2 now. Let's go on to question 2 now. So question 2. Okay, so suppose you work at a large health clinic and you are testing a new drug called Proloft that's meant to reduce depression in depressed adults. You measure the depression levels using a standardized well-being scale that gives a score from 0 to 20, with higher scores indicating greater well-being. You randomly choose a group of 60 depressed individuals and break them into 2 groups and record the depression level using the well-being scale. Next, you give a placebo, that means no drug, to group 1 and Proloft to group 2 for 1 month, and then record their well-being scores. The data below shows the results of your experiment, and write to our code. It does the following. So I basically have 2 groups here. Okay, let me move these down. So you have you got 2 groups. You got group 1 and group 2. They both have 30 people. So you record their depression levels at the beginning, and then group 1 is given the placebo, so given nothing, and then you record the scores after 1 month. Group 2 is given the drug you're testing, and then you record their scores after a month, and you want to see if they've improved using the drug as compared to the placebo. So the placebo group would be called the control group. Okay, so let's go down here. So A, we have to make 4 box plots. Let's do that. So box plot. So our first 4 box for the pre-treatment, green for the pre-treatment group 1. So orange one for pre-treatment group 1. So we basically have 4, 1 for each one. So we'll have pre-treatment group 1. Let's go up here. So here's the guys here. So this guy is 1. It's here. Then we have pre-treatment group 2. Then we have post-treatment group 1 with placebo here. So we're going to do 4 box plots. And then we'll have lastly post-treatment with the group, post-treatment group 2 with the drug. Okay, it goes here. Okay, and we want to now label the, let's see, main title. Let's see, depression levels before and after 1 month of treatment. That's our main title. We got that. And next, I want to name things here. So let's see, the names, so we're doing this part right here. So we'll add our names up here. So names. So our first guy is going to be pre-treatment group 1. Actually, it's going to be just all these guys. I'm going to put quotation marks around them. Let's put these guys here, and let's put a quotation marks around them. That's going to name them, each box plot. And this guy over here, 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 and here. And let's close this. Okay, we got the names now. So let's keep going. Now we need the colors. So colors. So the first one's orange. Next one, so we have orange here. Then green. Then so we did orange, green, yellow. And then red looks like. So close this and then close the whole box plot. So that should be it for the box plot one. Let me just double check. Yeah, I think we got everything for A now. So we got the box plot guy, so we can take that away now. Oops, just A. So now B computes the mean standard deviation of pre-treatment group 1, pre-treatment group 2, post-treatment, so for all 4 of them. Let's go through and do that now. Let's do it for pre-treatment group 1 first. So be print standard deviation and mean of pre-treatment group 1, so it'll be mean, then it'll be our group, standard deviation of our group. Then we'll just repeat this for the other ones. Let me just do that. Okay, so just repeat it for the pre-treatment group, oops, 2 here. So I did the standard deviation and the mean. Then I did it for post-treatment group 1 with placebo. So I did the mean and standard deviation here. And lastly, I did it for the third group, so that'd be the post-treatment group with drug. So I did the mean and standard deviation here. Okay, so let's keep going. We've done now B. Okay, so we need to do C now, but I'm going to stop it here and continue this in part 2. Let's leave it right here.